All right, in the next chapter, after this calculator chapter, we're going to be in quadratics and we're going to start factoring. And factoring is going to come up all year long. So we're going to get a jump start on this. So this is part of your homework classwork. You're going to get about 15 minutes after this video to work on this. I'm going to start with problem 5, show you one method, then I'm going to go to problem 6 and show you a different method. And I'm going to start with the hardened problems because if you can use the methods that I show you in 5 and 6 on all the problems, they're going to work. Okay, and I'm afraid if you do this quicker method that you can use on the first 4 problems, then you're going to get the other problems wrong. So we're going to start out with 5, and whether you do 5 my way or 6, which other teachers might show you, you're still going to want to make this x. So first you got to make sure this problem's in standard form. So the squared, the a, and then the number that's just by itself called the constant. And these are all in standard form, so you don't have to worry about it. What I'm going to do is I'm going to take the first terms, and in standard form, ax squared plus bx plus c, I'm going to take the first term and the last term and multiply them to get this. So 2a squared, and you need to realize that that's a negative 15. I'm going to have negative 30a squared. And then I'm going to take this middle term, I'm going to put a 1 with it just to have a number. And then you're going to look at your factor page. If you don't know the factors of 30, that can somehow get you to 1. And you're going to see that your choice is 5 and 6. So I'm going to put 5a and 6a. And right now, these don't work because I get positive 30 and I get 11a. So I need to make one of them negative. I'm going to make the 5 negative. So when I multiply these two, I get the negative 30a squared, and when I add them, I get the 1a. So what I'm going to do now is I'm going to rewrite this problem. I'm going to replace this term with these two terms. So I'm going to still have 2a squared, and I'm still going to have 1a, but now it's replaced with these two, because when I add those two together, I get 1a. And it doesn't matter which one you put first. So again, this is equivalent to this. I've just written, instead of 3 terms, I have 4 terms. And then once you get it into the 4 terms, you're going to group them. You're going to box the first two, or not box, parentheses around the first two and parentheses around the last two. And now what I'm going to do is I'm going to go to my first set of parentheses and ask myself, what can I factor out of this? What's the greatest common factor? Sometimes you can factor out of a number. In this problem, I can only factor out an a. So when I factor out an a, I'm still left with 2a here, and when I factor an a out of here, I'm left with a negative 5. The nice thing about this method is once you've done your first set of parentheses, the second set of parentheses is much easier because these parentheses will have to match. So if I have 2a plus negative 5 here, I'm going to have 2a plus negative 5 here. And then I go back and I ask myself, well, what did I factor out of 6a to get to 2a, or what did I factor out of negative 15 to get to negative 5, and that's a 3. And now I have my factors in front of me. One of the sets of factors is the matching set, but I only write it once, don't write them twice. And then the other set of factors are the things that are at the outside. And again, factors, if I take the factors and multiply them back, I should get what I started with. So for instance, just a quick version, if I have factors of 28, one set of factors are 4 and 7. When I multiply the factors 4 and 7, I get back to what I started with. So if I take my factored results here, these two sets of parentheses, I should get what I started with. So for instance, 2a times a is 2a squared. 2a times 3 is 6a. And then the negative 5 multiplies, and I get negative 5a. And then the negative 5 to the 3 gives me negative 15. So if you guys notice, this is just me showing you that this is going to work, is the same as this, a slightly different order. But then when I combine my like terms, I get back to this 1a. So factors, when you multiply them back, should give you what you started with. So this is one method. And again, I could switch these around. My work will look a little different, but I'll still get the same answer. So when I'm done, this is my final answer right here. These are the factors. So let me show you this other method in case you had a different teacher and she showed you or he showed you a different way. We got to do a little fixing here though. This minus 2n should become 3n, and then this 5 is going to be a negative 5. Alright, so I'm still going to make my x, and I'm still going to multiply these and get negative 40 n squared, and then my middle term, which I rewrote, is 3n, and now I need factors of 40 that get me to 3. So I'd look at my list if I don't know them, and I'm going to see that 8 and 5 will somehow get me there. Right now, though, they get me to 13n, so I'm going to have to make the 5 negative. So when I multiply these, I get negative 40n squared, and when I add them, I get 3n. So this method is called the box method, and I'm still going to rewrite this problem, but I'm going to put everything in a box. So the 8n squared goes in the top left corner, the negative 5 goes in the bottom right corner, and then again, this is going to be replaced by these two, and you can put these any way you want. So what you're going to do is you're going to start with your first row, and you're going to ask yourself, well, what can I factor out of both of these? What's the greatest common factor? And I can factor an 8 out, and I can factor an n out. The rest basically uses like a multiplication table. So what I need to do is put a number here, here, and here. And so I'm going to start with this number. So what do I have to multiply 8n by to make it 8n squared? And that would be an n. And then what do I have to multiply 8n by to get to 8n? That'd be a 1. And then here, to fill in this box, what do I have to multiply n by to get to negative 5n? And that would be a negative 5. And then if I multiply negative 5 and 1, there's the negative 5. And then the things that are on the outside of the parentheses become your parentheses. N plus 1 is one of them, and 8n minus 5 is the other one. It's basically the same work. You're rewriting it into 4 terms. Here I rewrote it into 4 terms. Here I rewrote it into 4 terms. And I'm still just factoring out. It's just, do you like it in a box or do you not like it in a box? And again, these are the factors. So when I multiply these, I should get to what I started with. So for instance, I get 8n squared, I get negative 5n when I multiply, and then when the 1 distributes through, I get a positive 8n and a minus 5, and then those will add up together and give me 3n. Okay, so from there what you should do is problems 5 and 6. I'm sorry, we just did 5 and 6, but you should jump to the back and try 7 and 8. And in case you can't see this, I'll rewrite them. This is 5k squared plus 24k plus 16, and this one is 5x squared plus 24x minus 5. Okay, I don't know what happened with the copier. Maybe it's running out of ink. When you're done with those, then you're going to go back and we're going to talk about the first 4 problems, but I'm going to go ahead and just run the video into that. So I'm going to do these problems the exact same way. There is an alternate way to do them, but I want you to stick with this method or this method if you're not good with factoring. Okay, if you're good with factoring, you'll see this quicker way, but I won't point that out to you right now. So again, if you can't see this, x squared minus 9x plus 18. The method I prefer is this method because this is similar to something that comes up later, but you're more than welcome to use the box method. So either way, I'm going to make my x. They're all in standard form. I don't have to worry. I'm going to multiply and get 18x squared, and I'm going to put my middle term, which I want to look as a negative 9x here. So now I need the factors of 18 that get me to negative 9 somehow, and I'm going to choose the 3 and 6. So I'm going to 3x and 6x. Right now, these get me to positive 9, so I'm going to make them both negative. So now when I add them, I get negative 9x, and when I add them, I get positive 18, and then the x squared. So I'm going to rewrite this. That negative 9x here is going to be replaced by this. So whether you rewrite this in a box or the way I'm doing it. And then once I have my 4 terms, I group the first 2 and the last 2. I want to look at this as a negative 6x. And now I'm going to ask myself, what can I factor out of both of those? And I can take an x out, and then I'm left with an x here and a 3 here. So just to show you, if I distribute that back in, I get the x squared. If I distribute that back in, I get the minus 3x. But I don't need to do that. All right, so now if this parentheses is x minus 3, then this set of parentheses is x minus 3. And then I'm going to ask myself, well, what did I take out of negative 6x to make it x, or what did I factor out of 18 to make it this negative 3? And I took out a negative 6. Again, if you bring that back in, there's the negative 6x, and then when I multiply this, I get the positive 18. And then my 2 sets of parentheses are the matching set is 1, and the things on the outside is the other. And if I multiply this back, I will get this step, and then when I combine my like terms, I'll get back to this step. So now you can finish 2, 3, and 4. Again, you can use the box method, you can use this method, whichever is better for you. And then just keep going. I'm going to talk about the back, the rest of the back. These are a little different because these only have 2 terms, and as it turns out, they're missing the middle term. They have an r squared, they have a constant, or a p squared and a constant, but they're missing the middle term. And these have a special name. This is called a difference of 2 squares. So I'm going to start with this one. Sorry, the copies didn't turn out well. First, it's a difference because there's subtraction. You might see it like this, but technically it's subtracting when you add the opposite. And then these are perfect squares. These have square roots, both of them. So what I do is in this method, when it's a difference of 2 squares, is I find those perfect square roots. So the square root of 25p squared is 5p. The square root of 16 is 4. And then those become my 2 sets of parentheses. And in them, I'll put 1 addition and 1 subtraction. So what happens, again, these are the factors. If I multiply these, I'll get back to what I started with. There's the 25p squared. That gives me minus or a negative 20p. Now when the 4 distributes, I get a positive 20p, and then what will happen is those will cancel out. That's why there's no middle term. And then multiply those and I get the minus 16. So I get back to what I started with. And these are all that way. These are all a difference of squares. So you should be looking for perfect square roots that go in your parentheses, 1 addition, 1 subtraction, or the subtraction go here and then the addition. So that's the first part. Your job is to watch the video, so I'm going to give you guys probably 20 minutes maybe around that to work on this whole thing. If she needs to give you a little bit more time, we'll bump it up to about 30.